Hello, welcome back to Pre-Calc. This is Unit 9, and we're going to be talking about Section 2, which we're going to be doing basic trigonometric identities, okay? Our objectives today, we want to identify and use the reciprocal identities, the quotient identities, Pythagorean identities, symmetry identities, and opposite angle identities. So what I want to do is list out our trigonometric identities for reciprocal, the quotient, and the Pythagorean identities, okay? And so the first thing I want to do is come in here, and we're gonna be writing a lot, okay, because I didn't write these out. But we're going to write out the reciprocal identities. Okay. And what I want to do is list out all of my trig functions. So I've got sine of theta, I've got cosine of theta, I have tangent of theta, I have cotangent of theta, I have secant of theta, and I have cosecant of theta, okay? So these are my 6 trigonometric functions, okay? And what I want to do is list out all of our reciprocal identities. So if I were to come in here and write the reciprocal of sine, I would write that as 1 over cosecant of theta, okay? For cosine, that would be 1 over secant of theta. If I were to do tangent, that would be 1 over cotangent theta. And cotangent, I would do 1 over tangent theta. For secant, that's going to be 1 over cosine of theta. And for cosecant, I would have 1 over sine theta, okay? The ones that I'm typically going to use here when we talk about the reciprocal identities are secant and cosecant. Those are the ones I'm going to use the most, okay? The next one I want to talk about is so here's my reciprocal identities. I'm going to box that in. I'm going to come over here and we're going to talk about the quotient identities. All right, so the quotient identities. Okay. Okay, and what I have when I talk about the quotient identities is mainly just 2 of them. Okay, tangent of theta and cotangent of theta. So I can write tangent of theta using sine of theta divided by cosine of theta. I can write cotangent as cosine of theta over sine theta, okay? And these are identities that we've talked about already, all right? A lot of these, but we're going to just be using them, all right? The next one that we have are the Pythagorean identities. So Pythagorean identities. Okay, and so remember the one that we have that's going to be probably the most important one is sine squared theta plus cosine squared theta is equal to 1. All right, I've got tangent squared theta plus 1 equals secant squared theta. All right, and then I've got 1 plus cotangent squared theta is equal to cosecant squared. Cosecant squared theta, okay? And so these are the ones I'm going to be using primarily. Now, what I want you to do, it's good to have all of these, but the ones that we're going to use the most is these, secant, cosecant. Okay. We will be using this one for tangent and this one for cotangent. Okay. And then we'll be using Pythagorean identities, and we'll primarily be using sine squared theta plus cosine squared theta is equal to 1. Okay. And so the reason why I highlighted those is because these are primarily in terms of sine and cosine. Okay, so secant and cosecant are written using sine and cosine. Tangent and cotangent are written using sine and cosine. Okay, and then the Pythagorean identities here. If you want to go back, if you go back to section 1 of this, I talk about how we develop these other identities. Okay, but we're just going to be using those to help us. So there's a number of ways of using these identities, but it's just important that we know what they are, okay, so that further down the line, there's a number of ways to do these problems. We kind of discovered that in section 1, how there's a way to do it by using a triangle to figure these things out. There's a way to do it by using the identities. So there's an algebraic way and kind of a graphical way, okay? So what I want to do in this next section down here, we want to use the trigonometric identities. So I have this first problem here that I want you to write down. And it says, I'll also do part A, if secant of theta is equal to 3/2, then cosine of theta equals what? Okay. And there's a couple different ways to think about this, okay? First of all, what I know is that these are reciprocal functions, okay? So if I know that secant of theta is equal to 3/2, I also know that cosine of theta is equal to 1 over secant of theta, all right? So I can use this identity here to figure out what cosine of theta is, okay? If I know what secant of theta is, which is 3/2, what I can do is I can substitute this value in for secant of theta, and I can get 1 over, instead of writing secant of theta, I can write what it's equal to, which is 3/2. And if I'm trying to evaluate what 1 divided by 3/2 is, okay, I can do 1 divided by 3/2, which is really the same thing as 1 times 2/3. So I would just get 2/3, okay? And that's what cosine of theta is, okay? That's one way of doing it. And that one's pretty simple, I think, to be able to find cosine of theta in this case. If I wanted to, I could draw a triangle, okay? Just a generic triangle, put theta here. If secant is the reciprocal of cosine, then that means that this would be hypotenuse over adjacent, so it would be 3 over 2, okay? And given that, okay, so I could write that, and if I wanted to write cosine of theta, that would just be my adjacent side divided by my hypotenuse, okay? All right, let's look at a different one. Let's look at part B on this, okay? So if I'm given, so if cosecant of theta is equal to 4/3, okay, then tangent of theta is equal to what? All right. So this one's a little bit trickier. And on this one, we could do a number of things. If I go back up and I look at my identities here, okay, we're given cosecant, okay, which is 1 over sine, okay. That's not going to do a whole lot of good for me to find what tangent is, okay, because in order for me to find tangent, I need sine and cosine, okay. I could use my Pythagorean identity here, okay. So I could plug this into my Pythagorean identity, figure out what cotangent is, and take the reciprocal of that. Or I could just draw a triangle, which I'm going to do, because I think that's the easiest way to do it. All right, so here's theta. Okay, here's my right angle. All right, and so cosecant of theta is equal to 4/3. Okay, now if I wanted to find sine of theta, that would simply just be the reciprocal of cosecant. Okay, so sine of theta would just be 3/4. Okay, and if I use the sine function, okay, then I'm doing opposite divided by hypotenuse. So I'm going to label this triangle with 3 divided by 4. And what I can do is I could use Pythagorean Theorem to solve for my missing side A. Okay, so that would give me a squared plus 3 squared is equal to 4 squared. Okay, so that would give me a squared plus 9 is equal to 16. So then a squared would be equal to 16 minus 9. So that would be, what was that, 7? A squared equals 7. Okay, take the square root of both sides. Okay, and that would give me that a is equal to the square root of 7. Okay, so if that length here is the square root of 7, then remember what I'm trying to find. I'm trying to find tangent of theta, given that. So then what I could do, tangent of theta is just opposite over adjacent. So tangent of theta, in this case, would be 3 divided by the square root of 7. However, we don't like to have square roots in our denominator. So I would multiply the top and bottom by the square root of 7. And that would give me tangent of theta is equal to 3 square root of 7 over 7. And that would be the value that I would want. Okay? So kind of tricky. All right, so on this next one, we want to use these things called symmetry identities. All right? And what I want to do, I'm just going to show you how I would go through these. It wants us to express each value as a trigonometric function of an angle in quadrant 1. Okay. So that's what I want to do. And so what I'm going to do is write these out, and I'm going to show you what I mean here. Okay, so express each value as a trigonometric function of an angle in quadrant 1. So the first one I want to do is sine of 600 degrees. Okay, and so what I would do, I can use these identities. They're really confusing. What I would rather do is just draw out my unit circle, okay? And let's talk about where 600 degrees is in the unit circle. So if I go around this circle once, that's a total of 360 degrees, right? So what I want to do is figure out where does 600 degrees land within my unit circle. So what I would do is I would take 600 minus 360 and see where we land, okay? And that's going to give me a value at 240 degrees, okay? So that's going to go around the circle once and then all the way around the circle until we get here, okay? So that's going to give me 240 degrees. And what we want to do is figure out what this point is on the unit circle. Okay? And so from here, what I can do is I know that that's the point negative 1/2, comma, negative square root of 3 over 2. Okay? But I want to express this value as a trigonometric function in quadrant 1. So really what this is, okay, if I wanted to translate that into quadrant 1, that would go up here, okay? And that would give me my 60-degree angle, okay? And so this point here would give me, what is that, 1/2, comma, square root of 3 over 2, okay? So if I evaluate sine of 600 degrees, okay, that's going to give me a value of negative square root of 3 over 2. But what I want to do is express this as a trig function in quadrant 1. So to show what that value would be in quadrant 1, okay, that would be sine of 60 degrees, okay, and that value gives me gives me positive square root of 3 over 2. Okay, but we want to get the opposite, okay, and what I want to do is this. I'm going to write this as negative sine of 60 degrees is equal to negative square root of 3 over 2, okay? This is weird, okay? And what I'm doing, and what you have to understand here is this word of symmetry, okay? If I take this point here, all right, at 240 degrees, negative 1/2, negative root 3 over 2, that would be symmetric to this point up here, all right, which would be 1/2 square root of 3 over 2. But for me to take this value and to put it as a value in quadrant 1, okay, I find that angle, which I think is pretty easy, but remember what we're trying to get is negative root 3 over 2, which gives me, you know, I would have to make this whole thing negative to make this part negative, okay? All right, let's look at another one, okay? Let's write this down as a part B question, all right? And I want to do the same thing for sine of 19 pi over 4, okay? So, you know, we're not evaluating this trig function, but what we're doing is we're going to express it as a sine value in quadrant 1, okay? So same thing, I'm going to draw my unit circle, okay? And I need to think about something. One revolution around this circle is 2 pi radians, okay? So if I were to think about one revolution as being 2 pi radians, so 2 pi radians over 1, if I wanted to get that in terms of a denominator of 4, let's get a common denominator of 4 here, so I'm going to multiply the top and bottom by 4. This is going to give me a value of 8 pi over 4, would be the same as 2 pi radians, okay? So then what I'd want to do is try and see how many 8 pi radians fit into 16 or 19 pi over 4 radians. So 8 pi over 4 and 19 pi over 4. Okay, so I would take 19 pi over 4. That's what I've got. 2 revolutions using 8 pi over 4 radians would be 16 pi over 4. Okay, and that's what's going to get me close to 19 pi over 4. And so 19 pi over 4, if I were to subtract off 16 pi over 4, that would give me 3 pi over 4 radians, okay? So what I'm looking for, okay, for me to get 19 pi over 4 is really the same thing as 3 pi over 4, all right, which is going to be here, all right? And so this is 3 pi over 4 radians. This point right here has the x value of negative root 2 over 2, comma, root 2 over 2. So now if I do this, all right, sine of 19 pi over 4 is going to give me the y value on this point in the unit circle, so that's going to be square root of 2 over 2. So if I wanted to write this in terms of something in quadrant 1, that would simply just be pi over 4 radians because it gives me the same value. So pi over 4 gives me the point root 2 over 2, comma, root 2 over 2. So I would write sine, my answer would be sine of pi over 4, something in quadrant 1, would be equal to root 2 over 2. And that would be my answer. All right, a little bit weird. Okay, and you can do the same things for the other trig functions, like you can do the same thing for cosine, tangent, cosecant, secant, all those other ones, okay? But it comes down to you know, taking whatever value it is and then expressing it in terms of quadrant 1, okay? The next thing I want to do is use this thing called opposite angle identities. And basically we have these things called proofs, okay? So what I want to do, I'm not going to go over what the opposite angle identities are. What I'm going to do is I'm going to simplify sine of x plus sine of x times cotangent squared of x, okay? And what I'm going to do is just rewrite this, okay, and get this down to a simplified version, okay? So what I'm going to do here is, for me to simplify this, what I'd want to do is I'd want to rewrite cotangent squared of x. And the whole point of this is to put this in terms of sine and cosine, okay? So what I'd want to do is I would do sine of x plus sine of x times cotangent squared of x. How can I rewrite cotangent squared of x in terms of sine and cosine? And what I could do is I could say cosine squared of x divided by sine squared x. Okay? And I could simplify it like that. And then what I notice here is that one of my sines divide out. This would divide out to 1, and this would just divide out to sine of x. So what I have left over is this. I have sine of x plus cosine squared of x divided by sine of x. Okay? Once I have that, I realize that I have one trig function added to another trig function, and my denominator over on the left side is 1. The denominator on my right side is sine of x. Okay? Now what I'd want to do is write this as one fraction. So what I could then do is multiply the top and bottom by sine of x over sine of x. Now in the top part, if I take sine x times sine x, that's going to give me sine squared x over sine of x plus cosine squared x over sine of x. All right. Now when I have a common denominator like this, okay, I can write this as one fraction. And I can write sine squared x plus cosine squared x all over sine of x. Well, wait a minute. What does sine squared x plus cosine squared x equal? 1. So, those are the kind of things I want to do here, is just, simplify it. If I'm adding two things, I want to combine them, okay, as something. And so what I could then do is I could write this as 1 over sine x, which is really just cosecant of x. And that is simplified. So one of the things that they will ask you to do is to take something like this, some crazy expression, simplify it and turn it into one of our original trig functions. Okay, and that's the hope, or a number, it depends. All right, so the second page is a little convoluted and weird, but I will work through the quiz with you. And so let's go ahead and get started on that.